So let's look at part 3a. So the curve C and the line N are both transformed by a two-way stretch. Scale factor of 2 in the x direction and scale factor of 3 in the y direction. So the x direction and the y direction for C and N. Alright, so meaning to say they will just do a two-way stretch test to form the curve D and line M. Alright, find the enclosed area by D and M and the x-axis. So essentially, everything will be stretched in the same direction. So it's just a mark. So there's a faster way to do it instead of just finding the equations separately. So this is what I'll suggest. If you are not too sure how this is going to pan out, what we could do is actually just try and draw something. Okay, the shape will be the same, right? So for say if we have a triangle as such, and this is like a x unit and this is a y unit, right? And it say that we just follow the same exact same method. We have a two-way stretch, scale factor of 2 in the x direction, so it becomes 2x, and this becomes 3y value here. Okay, so in other words, this should be higher. This is much higher. I'm just gonna use this illustration, very quick short illustration here. So the area here will be half times base times height. The area here will be half times base times height, right? So this case here, if you were to do this same logic here, it's a very sort of like a very straightforward way. But if the ratio of the area would then be half to 3 and there'll be 1 to 6. Am I right? Okay, so similarly, what you have just done there is the new area, the area enclosed will just be 1 to 6. So I'm going to take the previous part, 18, multiply by 6. That will give us 2057 over 3, and this will be units. Okay, so that's how you do this part quickly. Of course, you can use other methods to go and try and find it, but this is just an example. If you want to use the longer way, is also possible.